Hi, my name is Muhammad bin Sulaiman, matrix number 01 DPU20F1053. I'm from DPU3B class. Today, I would like to share about heat exchanger. Now, I'm going to talk about introduction about our topic. A heat exchanger is a system used to transfer heat between two or more fluids. Heat exchangers are used in both cooling and heating process. The fluid may be separated by a solid wall so that they never mix, or they may be in direct contact. Heat exchangers are widely used in air conditioning, petroleum refineries, chemical plants, petrochemical plants, natural gas processing, refrigeration, power plants, and space heating. Next, I will talk about the objective. First objective is recognize what is heat exchanger. Next, differentiate numerous types of heat exchanger, their classification and their applications. Then, know the heat transfer equipment terminologies and know the primary consideration in the selection of heat exchanger. Next, I will talk about the main advantages. First advantage is high flow rate of the coolant. This is achieved through careful selection of water pipes of the desired diameter, which allows the medium to flow freely inside the pipes. Next, ease of maintenance. This property makes it possible to carry out regular cleaning of equipment, which allows to increase the duration of its operation. Then, versatility in system. It is permissible to use a coolant both in the liquid and in the vapor phase. Next, I will talk about the disadvantages. First of the disadvantages is dimensions. Due to the large size, difficulties arise during transportation and use of the device. Most of all, this refers to individual use, where space is very limited. It is high cost. The price of external pipes that are not involved in heat exchange and which are connected to the heat exchanger is quite expensive. And lastly, difficulties in the design. When choosing the equipment, you must contact the professionals, which is associated with the complexity of the calculation. At the same time, the overall cost of manufacturing and installation will increases.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Danish Hazim bin Zaman. My matrix number is 01 DPU20F1040 and I'm from DPU3B. I will continue the presentation. The type of heat exchanger. So we know heat exchanger has many types, such as double pipe heat exchanger, shell and tube heat exchanger, plate heat exchanger, spiral heat exchanger, and lastly, plate and shell heat exchanger. Next, we go through the parallel flow heat exchanger. This flow arrangement is called parallel flow. Heat is transferred from the warm fluid through the wall of the inner tube, the so-called heating surface, to the cold fluid. A heat exchanger can also be operated in counterflow, in which the two fluids flow in parallel but opposite directions. Concentric tube heat exchangers are built in several ways, such as a coil or in straight sections placed side by side and connected in series. Next, I will talk about objective. The design of a parallel flow heat exchanger is advantageous when two fluids are required to be brought to nearly the same temperature. The more uniform temperature difference produces a more uniform rate of heat transfer throughout the heat exchanger. The outlet temperature of the cold fluid can approach the highest temperature of the hot fluid, or we call that as the inlet temperature. Next, I want to talk about the advantage and the disadvantage of the parallel flow heat exchanger. I will talk about the advantage first. The parallel flow is used when fluids should exit at the nearly same temperature. Next, the disadvantages. Large temperature differences at the inlet, or large thermal stresses, and cold out can never exceed hot out. I think That's all from me. Thank you.
Hi, Assalamualaikum. My name is Hafiz Izuan bin Muhammad Zubi. My matrix number is 01 DPU20F1034. Okay, today I want to present for the conclusion heat exchanger. Okay, so the conclusion, the main basic heat exchanger equation is okay, the inside is this is a formula Q equal U multiply A multiply ATM. Okay, for the A is heat transfer area, for the Q is heat transfer rate, for the U overall heat transfer coefficient, for the ATM log means temperature difference. Okay, for the next, the log's mean temperature difference ATM is at inside. This is the formula T1 inlet tube inside fluid temperature, T small 2 outlet shell side fluid temperature, T2 outlet tube side fluid temperature, T small 1 inlet shell side fluid temperature. Okay, this is the question. Calculate the log mean temperature difference ATM. So the other side in cool side water in 15 Fahrenheit, hot side process out 114 Fahrenheit, hot side process in 119 Fahrenheit, for the cool side water out 19 Fahrenheit. Okay, for the solution is T1 light oil hot side, T small 2 water cool side, T2 light oil cool side, T small 1 water cool side. For the formula is ATM in bracket T1 minus T small 2 minus in bracket T2 minus T small 1. Lyons in bracket T1 minus T small 2 per in bracket T2 minus T small 1. For the next ATM, in bracket 119 minus 19 minus in bracket 114 minus 15 in Lyons, in bracket 119 minus 19 per in bracket 114 minus 15. For the answer is 100 minus 19 in Lyons, in bracket 100 per 19. For this answer, 10 per 0.10536. For the final answer is 994.9 Fahrenheit. So that's all for my group. Thank you, madam.